Good evening, everyone. This is June 2020, Unit 4 PH1, Paper 2 PR for IGCSE Physics, International GCSE, and grading from 9 to 1. The first question. This question is about electrostatics. A student uses a plastic rod to investigate electrostatics. Describe how student could have charged the plastic rod because it's an insulator. So when we want to charge an insulator, we can rub with another insulator. Because to charge an insulator, we use electrostatic friction, and to charge the conductor, we use electrostatic induction. So we can rub with another insulating material. The meter displays 5.2 millicoulomb. So which of these is the same? So when we move the point 1, 2, 3, so that will be equal to minus 5.2 into 10 to the power minus 3 coulomb, and minus 3 is actually equivalent to milli, so it will be 5.2 milli coulomb. That's why C will be the right answer. The rod is negatively charged. Which statement correctly explain why the rod is negatively charged? Because if it's a negatively charged, it gain electron, because when substance gain electron, it will get a negative charge, and if the substance loses electron, it will get a positive charge. So because it is a negative charge, so it has gained electron, so that's why the net charge is negative. Using a meter is one method of demonstrating that rod is charged. Describe another method to demonstrate that the rod is charged. So what else we can do? We can use a water stream from the tap, and we can place the object if the stream deflect. It shows it is the object is charged. Electrostatic charges can be useful, but they can also be dangerous. Give one use of electrostatic charge. So we use in inkjet printers, or it is also used in dust precipitators. Explain why electrostatic charges can be dangerous when fueling in airplane. So when refueling or fueling an airplane, why? Because the charges can produce a spark. So the fuel may catch fire. Next question. X-rays are electromagnetic waves used to obtain the image of bone. An X-ray machine produces X-ray with a frequency of 1.25 exponent 18 Hz. Calculate the time period. Time period and frequency are reciprocal to each other. So T is equals to 1 divided by F. So 1 divided by 1.25 into 10 to the power 18. So this will give us the time period, which is 8 exponent minus 19 seconds. X-rays have a speed of 3 exponent 8 meter per second in air. Calculate the wavelength of these X-rays. So we have the formula V is equals to F lambda. So V, the frequency, which is given 1.2 into 10 to the power 1.25 10 to the power 18. And the speed is also there, which is 3 exponent 8. So speed is 3 into 10 to the power 8 and 1.25 into 10 to the power 18, and we need wavelength. So the wavelength will be 3 into 10 to the power 8 divided by 1.25 into 10 to the power 18. So we'll get answer in meters, which is 2.4 into 10 to the power minus 10 meters. The builder needs to lift a large stone block. The diagram 1 shows a stone block. Draw on X on diagram 1 at the center of gravity of a stone. So the point where the weight of an object at, that is the center of the gravity. State a formula which relate weight, mass and gravitational field strength. So weight W is equals to mg. So weight is equals to mass times the gravity. The mass of the block is 130. We need the weight, so gravity will take us 10. So it will be 1,300 newtons. The builder uses a wooden plank to lift large stone block. The plank is uniform and pivoted at its center. The builder pushes down from one end of a plank to lift the stone block. The diagram 2 shows a plank when it is horizontal and stationary. State the principle of the moment. According to principle of moment, object is in equilibrium and there is no resultant moment, or the clockwise moment equal to anti-clockwise moment, and no resultant moment, we can say, or we can also say there is no resultant moment acting on the object. The builder is pushing down with a force of 520 Newton to keep the plank horizontal. Calculate the distance. So the clockwise moment balances with the anti-clockwise moment. So this is causing a clockwise moment, the weight is causing anti-clockwise. The distances are given. Weight of a block we already calculated, 1300 multiplied by distance from the pivot 0.3. Distance x is there and the force is 520. So x will be 1300 into 0.3 divided by 520, which is equals to 0.75 meter. So this is x. Calculate the length of a plank. So because the pivot is placed at the center, so if this was 0.75, the other half will also be 0.75. So it will be sum of 0.75 plus 0.75 equal to 1.5 meter. A student investigates the speed of sound in air. Student set up two microphones A and B as shown in the diagram. Microphone A, source of a sound, and microphone B is also shown. Microphones are connected to data logger. Sound is made to the left of the microphone A. The data logger records the time when the sound wave reaches each microphone. The student uses the data to calculate the time for sound to travel from microphone A to B. Describe how student could determine the speed of a sound in air using his calculated values of a time taken. So student can use the formula speed is equals to distance over time. So student can measure the distance between the two microphones by using a formula. Measure distance between microphone A and B by measuring tape or meter rule. and use the time values to get the speed of a sound between A and B. Suggests why the student does not use a stopwatch, because this time interval is very small. A short time interval is there, so it will be difficult to measure by using a stopwatch, because we have our reaction time. It will be difficult to identify or measure the interval accurately as possible. Maybe because the time interval might be smaller than or shorter than our reaction time. So time interval is too small. That's why we are not using a stopwatch. We are using a data logger. Student investigated how the speed of a sound in air varies with temperature. He places several Bunsen burner in the same space between microphone A and B as shown in diagram 2. Light all the burners on a low heating flame, then measure the air temperature in 3 places between the microphone. Use the data logger, record the time for a sound to travel from microphone A to B and determine the speed. Student repeat this method as the air temperature increases. Suggest why it is important for all burners to burn at the same amount of gas each second, so that the temperature of air between A and B will be same. Otherwise, what happen? Some regions you have high temperature and some regions you may have low temperature. The table shows students' results. Calculate the mean temperature for the last row. So how to calculate a mean temperature? You will add them and divide it by 3. So it will come out as 59.97. But as you can see, all the values are 1 decimal place. So if we have 59.97, when we round it off to 3 significant figure, so it will be 60 point. You can write 59.9 or you can write as 60.0. The student plots his results and draw the line of best fit. Draw a circle around anomalous result. So the point which appeared outside this range does not appear on the pattern. That's anomalous result. State how students should deal with anomalous. So what he can do, either he can discard this result or he can repeat the values for this anomalous result. So it can be discarded, you can discard, or you can repeat for same value. Explain why a line graph is correct type of graph to display these results. So why the line graph is a correct graph to display this result? Because this is a continuous data, and for continuous data, line graphs are suitable. So data is continuous. Describe a relation between speed of sound in air and temperature. So you can see it's a straight line which is a constant, having a constant gradient. So, but why we cannot use the term proportional here? Because the graph is not starting from origin, and we don't know, because we don't have the values from 0 and 0. Maybe it may start from origin or may not, but the thing is we don't have that scale, so we cannot say they are directly proportional, because when two quantities are directly proportional, there should be a straight line which starts from origin. So you can say as temperature is increasing, the speed will also increase, and because it's a straight line graph, so they have a linear relation. So increase in temperature increase speed of sound in air, and they have linear relation. Why linear relation? Because it's a straight line, shows a relation is a linear. Question 5. Energy is transferred from sun to earth. The nuclear fusion happened in the sun. Which energy stored in the sun decreases during nuclear fusion? So nuclear energy decreases. How the energy transferred through the space? So through the space by electromagnetic radiation. B is the right answer. Solar panels use energy from sun to heat water. A total area of solar panel is 15 meters square. 1 meter square of solar panel receive 1000 joules per second from sun. Show that the total energy transferred to solar panel in 2 hours. So we have the formula. In 2 hours, so as I mentioned, 1 meter square receive 1000 joules. So 15 meters square will receive X. When you multiply, it will be 15,000 joules. That is receive each second. But what we want for 2 hours. So we'll convert the time, the 2 hours into second, because this is for 1 second. So this is the energy which we receive in 1 second. So in 2 hours, 7200 second, we will receive X. So cross multiply, which will come out 108 megajoules of energy. The mass of 1100 kilogram of a cold water is in a solar panel. Initial temperature 20. Calculate the final temperature of this water after being heated for 2 hours. So we'll have the energy, we have the formula Q is equals to Cm delta T. The energy which is intake 108 megajoules. Specific heat is 4200, the mass 1100, and temperature change, because the final will be higher, so T2 minus 20. So the final temperature, when you solve this, it will come out as 42. Give a reason why actual final temperature will be lower than, because here our assumption is that all of the energy is transferred to the water, but maybe the process is not 100% efficient. Not all of the energy transfer to water, so this may leads to inaccurate, like smaller final temperature. Conventional power stations burn fuel in a furnace. Fuel can be a solid, liquid, or a gas. So we may have a fuel in a solid state, we may have a fuel in liquid state, and we may have a fuel in a gaseous state. So we have to describe the motion of the particles in solid, liquid, and gas. So in solid, what happened? The particles vibrate only about fixed position. In liquid, the particle can slide over each other. Vibration is there for all kind of all the three states, solid, liquid, and gas. And for gases, the particle vibrate and move randomly. When the fuel is burned, energy is transferred from the fuel to water. The water boils and turns into steam. Describe how energy stored in the fuel is transferred to water. Refer to energy stored and the transfer in your answer. So the fuel which we are using, that is having a chemical energy. So fuel store chemical energy, and then when we burn the fuel, energy transfer is heat in the form of by convection or radiation, and that's stored as internal energy or heat energy in the water. The temperature time graph shows how the temperature of a water changes as heated in the furnace at a constant rate. So as the temperature, how the graph shows water changes state, because the temperature is constant, horizontal line which shows temperature is constant, so there will be a change in state. Whenever the temperature is constant means there is a change in state, because during the change in state there is no change in temperature, and we can identify when is the horizontal line for time on x-axis and temperature on y-axis. A machine called synchrocyclotron (SC) was designed to cause a proton to move in a circular path using strong magnetic fields. SC used electromagnet to produce a strong magnetic field. Describe the construction of a simple electromagnet. You may draw a diagram to support your answer. So basically what we have, a coil made up of copper which turn around on a soft iron core connected to the supply. So the iron core is there, this is a coil, and we have a power supply. The coil is made up of copper, we have soft iron core, and we have a supply, which source of energy. So when there is a current in the coil, it produces a magnetic field which magnetize this iron core, and it will behave like a electromagnet. The diagram shows a proton moving at a velocity v in a magnetic field. The direction of a magnetic field is into. So your first finger should point into, your index finger should point into, and your second finger should point on the left hand side. Where your thumb is pointing, your thumb automatically will point downward. So the force or the deflection will be down. So this will move in a curved path. SC is surrounded by a very thick concrete wall. The radiation produced by the SC created atoms of radioactive barium-133 in the concrete walls. Barium-133 has a half-life of 10.5 years. What is meant by the term half-life? Half-life means the time taken by half of the radioactive sample to be stable, or time taken by half of the radioactive sample to decay. So how much time half of the radioactive sample will take to decay? That's called half-life. In 1990, the SC stopped being used at CERN, a research center. 1990, the largest number of barium-133 atoms were found, 40 centimeter deep in a concrete walls. Since 2014, the members of the public has been allowed to visit SC at CERN. Explain why radioactive barium 133 in a concrete wall is not a risk to people visiting SC. So people visiting SC, it's for a short time, so they're exposed to radiation for a short time, as well as this barium, as we know, the half-life is about 10.5 years. So it is approximately like from 1990 to 2000, and from 2000 to 2010. So if originally it was 100% sample, then 50% barium will be there, and then 25%. So only 25% barium is left. So it reduces the emission as well. And because it is exposed, the people who are visiting the site are exposed for a short time. That also reduces the risk of the exposure of radiation to the visitors. The Big Bang theory suggests that the universe is approximately 14 billion years old. Describe the evolution of universe from Big Bang until the present day. So basically, the Big Bang, what we can say about the universe, that in the beginning, because according to Big Bang theory, the universe was very dense and hot. But the universe is expanding since the Big Bang, and it has cooled down. So universe in the beginning was dense and hot. The universe cooled down since the Big Bang, and continuously expanding. Describe the evidence that support the Big Bang theory. So there are many evidences for this Big Bang theory which support this Big Bang theory. Number one, the background radiation, the microwave background radiation or cosmic microwave background radiation. So these cosmic microwave background radiation, because we are receiving from all the direction these cosmic background microwave background radiation, and initially, because it's in a longer wavelength, initially it was in a shorter wavelength, but as the universe is expanding, and it cooled down, we observed that the wavelength is increasing. So the presence of the cosmic background radiation which comes from all direction, that and the radiation, the background radiation began with gamma, and the wavelength increased as the universe is expanding. Then another thing, the Doppler shift, using a Doppler shift we are getting mostly redshift from the galaxies. Shows they are moving away from each other. And the fastest galaxy shows a greater redshift. The further one, which are the faster one, because when the distance increases, the recession speed at which the galaxies are moving away, that is also increasing up, and that is given by the Hubble's law that v is proportional to d, the speed proportional to the distance of the galaxies. So the further and the faster galaxies shows greater redshift, and the amount of helium also indicate that universe was warm or hot, not warm, it should be a hot enough to fuse protons, because proton fusion release helium. So these are some points which shows the evidence that supports the Big Bang theory. You don't have to write all of this. You can take 1 or 2 points from this and write your answer. So this was the last question from paper 2PR.